think 26 participants were joined. So previous class, still we completed till race conditions. I think so. Okay, till that we completed till race conditions. Today and ISRs and scheduling also we completed. We completed this topic also. So only two topics left out in the 50th unit. One is priority invention and another one is inter-task communication. Only these two topics left out. The remaining and all we covered. Okay. I think we directly move on to the priority invention slide. Okay. So race condition we have discussed yesterday. What is race condition and what is mutual exclusion? And then we have seen about ISR. Okay, interrupt service routine and scheduling using preemptive and emptive algorithm. Then we discussed about semaphore. Okay, anyone tell me what is semaphore? What is semaphore? No one. I have put that particular PPT for you only. Anyone can kindly tell what is semaphore? No one.
Protocol mechanism.
Yama, Aruna Devi, tell me.
Protocol mechanism, ma'am.
Protocol mechanism for multitasking kernel. Okay, actually what it will do now, this is the three purpose of semaphore. One is it will do mutual exclusion. What is mutual exclusion now? Two tasks come at a time. It will decide which task has to be done, or else we have to share the resource. That will be decided. And number of occurrence of the event. And the third one, allow two tasks to synchronize their activity. Okay, so that is a semaphore. It is a protocol mainly deal with the multitasking. Good, Aruna Devi. So I have told you semaphore will be in a binary form or in a counting form. So that's why I think you can see this diagram. Task one, task two. So two thing will be there. Semaphore just they put it as a key. Can you see? That's a key symbol which has to be print first. Okay, whether it is a task one or task two, giving a permission, the particular task will be printed first, and the next this task will be printed. Okay, so uh, now counting. I told you one best example, the restaurant and waiting table. Now waiting table means table available in the restaurant. So when the restaurants open at morning, you have seen all the tables were vacant. Okay, none of the table is occupied. Once it begins, what happen? The people slowly comes. So whenever the people occupies the table, first the waiter will keep the water. That means the particular table is occupied and the concerned person has to be um, occupied there, and they have to serve the food. So while seeing that entire table is occupied now, the entire task is under the queue. So if any new person is coming, they were not allowed to come inside. They have to wait outside. So that is waiting task. And then they will see according to the resource whether a two tasks can be accommodated in a single table, or two families can be accommodated in a single table. They will try to occupy the resource. They will find out that. So they have explained the counting semaphore analogy in the restaurant table. Okay, now we will enter into the new topic, priority inversion. Okay, actually it having only 3 slides to explain the priority inversion. Okay, so priority means what? It is a task which is assigned that whether it is a higher priority or lower priority, whether we have to put the attention first or else we have to give the least attention. So that is priority. So here they have given static priority, dynamic priority. Static means from the name itself we can clearly say that the priorities be fixed all the time. That won't change, it will always static. The priority of each does not change during the application execution. So in automobile car, the static priority instance means, uh, if I'm having the airbag, it has to be highest priority. Now whenever the application runs, it will be in highest priority only. But at the same time, dynamic priority, now I already told whether wiper is not working or your power window is not get closed and all. But when you take ABS, anti braking system, and your airbag will becomes under static priority, it won't change, it will be always in the higher priority. But dynamic priority, radio is not working on that, or your dashboard speedometer is not working, or your power window is not closed, or the child lock is not working, or your wiper is not working, that will be depending on the circumstance, it comes under dynamic priority. Okay. Priority invention, what is the next one I am saying? Priority inversion. 48 students are there. Why ma? Actually the time is almost 8:38.
Ma'am,
Yeah, tell
you
me.
are having TCS exam, ma'am, right now, like
Today?
our class.
Oh, your class having TCS exam, huh? How
Yes,
many
ma'am.
of them were writing, ma? You don't
No,
know that
no,
strength, huh?
no, don't know. Hirok is writing them right now.
Huh?
Hirok is writing exam.
Hiroki-sen. Okay, okay, okay. So okay, ma'am. So we will continue the topic. Priority inversion. What is priority inversion? I think from the name itself, you can understand that priority of the task is get inverted. Inverted means what? If it is high priority, na, that will become low priority. If it is low priority, na, that will become high priority. That is priority inversion. So we are going to concentrate on the priority inversion. So priority inversion means priority get inverted. Okay. Priority inherit means the priority of the task is get inherited. Inherited means what you have to understand. You just kindly see this. Um, priority invention means low priority involves a low priority and blocking a high priority task. Are you clear? Low priority means what? You all understand. Low priority will be blocked. High priority will be involved. But here priority invert means inverted. 1 bar na 0, 0 bar na 1. The same way, it involves a low priority task, but similarly, it blocks the high priority task. Okay. One way to priority inversion is to avoid blocking. Okay. Sometimes we have to invert the blocking. At that time, the priority invention will be involved. Are you clear or not? So we will see that. Um, what is priority inheritance, and we will see with one an example. So they, that's why they have given one simple definition here. uh, you just see this. Priority invention means a problem, while priority inheritance means the solution for that. Are you clear? Priority invention means problem. Someone unmuted their mic. Okay, ma. So I think you have understand what is priority invention. Oh, anyone tell what is priority invention, ma? I told you now definition, na? Can anyone tell what is priority inversion?
Like scheduling the task according to the time what we require.
Not scheduling.
That means changing the task over a period of time.
Inverting the task. Priority inversion means inverting the task. Inverting means what? Low priority become involved and high priority become blocked. Normally what we will do, we will block the low priority and we will involve the high priority, but it is the opposite. And okay, so low priority task will be get involved and high priority task will be get blocked. That is priority inversion. That is a problem. Priority invention means it's a problem. Priority inheritance means solution for the priority invention. Okay, now I think we will slowly move on to the next slide. So students, I'm just flip one slide into another. Okay, so you kindly, I think, wait for one more time. I have one more idea. God. Yeah, students, I will share you once again. I think I have decided to something, but it's not working out. Okay, ma. So please, students, priority invention means you are supposed to explain this diagram along with this. Okay, so I will move my PPT and I will explain you. Please understand this diagram. This is only thing how to explain. Okay. So priority invention, it's occur in real time RTOS. Okay, when you use the real time kernel, you all understand that here we are all real time. Real time means when it will be always used in the real time only. Okay, you have to know that it has to be used according to the user conditions. Okay, so you just see how they have given here uh, three tasks they have involved for this explaining the priority. Task 1, task 2, task 3. So task 1 has a higher priority. Task 1 has a higher priority than task 2. Then task 2 has a higher priority than task 3. So which is highest priority? Ma? Task 1. The next highest priority is task 2. The least highest priority is task 3. So the level of priority from higher to low, na, the highest priority is task 1 and the lowest priority is task 3 and the intermediate priority is task 2. Are you clear? Have you understand or not? That's why they have given, see, task 1 high priority, task 2 medium priority, task 3 lower priority. Okay, now we will see task 1 and task 2 both waiting for an event to occur. Thus task 3 is executing. That means task 1 and task 2 want to be executed now. Okay, task 1 and task 2 get to be executed. But what happened now? Now the task 3 is executing. We all know what is priority invention, ma? It will do opposite. So the two highest priority task is not involved, which is they are running task 3. Why? The lowest now it will become highest priority. So what happened? They are running the task 3 priority. So the same thing they are saying, task 1 and task 2 both are waiting for an event to occur, but task 3 is executing because this priority is get inverted. Okay. At next, at some point, the next point, you just see we have a 12 executions where here also we have explained with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. The 12 steps is explained with this diagram. I think this is the best example they have given for the priority invention. Okay. So next one is at some task 3 acquires a semaphore. Okay. That it needs before it can access a shared resource. I told you that semaphore remains, it is a protocol which always does the multitasking. So if I want to do any shared resource, or if I want to count any signal event, or if I want to do any mutual exclusion, Mutual exclusion means which task has to be done first. That is, we have seen with the race condition. The race condition, the solution is what? Mutual exclusion. So the task 3 occur that semaphore. It is having that protocol. So it only allocate the resource, whether task 1 has to do or task 2 has to do. That control will comes under which ma? Task 3. So now you go to the next slide and see. Now task 3 get a semaphore key. Have you seen semaphore? I have shown you the symbol key. So the key denotes means task 3 get that semaphore. Are you clear or not? Task 3 get that semaphore. Okay. Now you see it gets preempted by high priority task 1. Preempted means earlier or before. That is the meaning for the particular word. So it gets preempted by the high, even though what they were saying, the task 3 get a semaphore, task 1 preempts task 3. But what happened? Task 3 only now in the highest priority, and task 1 is in the lowest priority. Even task 1 tried to get that semaphore, but now the task 3 only having that key. So what happened now? Task 1 preempts task 2. So what happened? Now the task 1 is get involved. Okay. So why? Because now this is having, even though lowest priority, the task 3 is having a multiple resource handling. So it allows task 1 preempts task 3. Preempts means what I have told you earlier. Okay, before the semaphore, it gets earlier before that. So now task 1 is trying to get the semaphore, but semaphore is having which task ma? Task 3 only having the semaphore. Are you clear? So what happened? Task 1 is trying to that high priority task. It is getting the semaphore. But what happened now? Task 3 only having that semaphore. Okay. So what we have to do, that is the task. So here the sixth step what they have given now, task 1 tries to get the semaphore, but the kernel notice the semaphore is already owned by what? Task 3. So task 1 is get suspended and task 3 is resumed. Are you clear or not? So semaphore is having with the key is having with task 3, but task 1 is try to occur that semaphore. But the kernel is deciding which is having semaphore. Task 3 only is having semaphore. So what it doing is suspending the task 1 and task 3 get resumed here. Have you seen? So the task 3 is resumed. Now task 3 take the position. Okay. Now the seventh step. So task 3 continue to execute until it gets preempted by task 2. So once what happened? Now the task 2 will be enter into the region. So what happened? In the eighth step, we were task 2 is now preempted. Task 2 is earlier. Task 2 is earlier than task 3. So what happened? It will now take the position. So now just to see at this eighth position, task 2 is now taking the position. So it is get executing. Now what happened? The ninth step means what ma? Task 2 relinquishes the CPU back to task 3. So what happened? Relinquishes, we have you heard this where you studied? Did you remember where you studied relinquishes? I think in DMA controller. Okay. Once what happened? What is DMA ma? What is
Direct
the
memory access, ma'am.
Yeah, direct memory access. So what happened? Every time a CPU get involved, the timing will be get delayed. So what happened? This DMA will own the system bus, that is control bus, address bus, data bus and all. So it will ask the permission of the CPU. I need all this bus. So what will the CPU will do? CPU will relinquish this all these buses. That means it will give the authority to DMA and it will leave it, drop it. That is the meaning for that. Relinquishes means drop it. It will drop it. So what happened? Now task 2 is entering and it is executing. So once in the ninth state, okay, I think in the ninth state, what happened now? Task 2 relinquishes, task 2 drop the CPU and automatically now task 3 get the position. So once task 3 get the position, now task 3 resumes. Okay, now task 3 is resumed to and it try to finish with the resource. So once it finish, then it releases the semaphore. I have completed. Now you have the key with you. It will release the semaphore. So once it release the semaphore, task 1 will acquire the semaphore. Can you understand that? This is the priority invention topic. So what you have understand now, all the authority will be get changed. That is the thing. So this is high priority, this is medium priority, this is low priority. Listen, I will repeat once again. So I will tell you in very crisp. So first what happened, the priority inverted. So task 3 become high priority. Now it is running the task of the task 3. Once it running, it is in the high priority. So what it will do, what is the main thing? I need a key. What is key for me? Semaphore. Semaphore is the protocol that is owned by now task 3. So task 3 get that semaphore. So once task 3 get the semaphore, now task 1 want to execute the task. So it is allowing to execute the task 1. But what happened? Task 1 having the I have to handle the key. Why task 3 is having? So it is tries to get the semaphore. But what happened now? Task 3 is not allowing to get the semaphore for task 1. So what happened? Again task 3 get the position. You are try your time is given to only to execute the task, not to get the semaphore. So what happened? Task 1 get relieved, and now what happened? Task 3 will resumed. So once task 3 is resumed, again now task 2 is coming. I want to execute my task. So what happened? The task 2 is now executing. But you all know it is a medium task. So it know, well, I won't get a semaphore. So why I have to try that? So it is after executing the task, it is completing its work. And then what happened? It is dropped the CPU bus. Once it drops, what happened? Task 3 get resumed. So once task 3 is ready, I'm having the key with me. So I have to, what is the key of that? Key means what? Semaphore. So I'm having the only the key. So I have to complete all my resources. After completing all the resources of task 3, it will release us. Now you have the semaphore. Now task 1 will acquire that semaphore. Have you understand priority invention, ma? Have you understand or not? Anyone kindly tell? Are you there, people?
Yes, ma'am.
Yes, ma'am.
Yeah, okay, ma. So I think this is a priority invention. With one single diagram, you can explain it. Are you clear? Okay. Now the time is 8:54. Okay, who are all going to take the seminar, ma'am? The next topics. So only one topic is left out in the 50th unit. That is inter-task communication. That I will continue. Who are all going to take the seminar?
Ma'am, Jai Shri ma'am.
Jay Shri. Then next. Then next. Who all? Only Jay Shri. Yeah. Only Jay Shri. Okay, Jay Shri. Okay, now we will discuss the question paper, ma. Then we will move on to the question. Okay.
Okay, ma'am.
Yeah. So students, kindly note down I'm not very sure. Don't think that ma'am will ask this same question. I'm trying to discuss the answer with you. That's it. Okay, how to write and all, I don't know how far you have studied. So today, last time, I have a very worst experience with you people. It's clear. So while I'm explaining, you have written something. If I ask about orange, you will write about apple. That has happened yesterday, last class. Last time I ask about ports, you will write about pin diagram. Okay, what is happening? I don't know. So don't do such a things this time. Are you clear on that? You have to be very particular, and you have to be write very correctly according to the question. Okay, I think I will share. Okay, people, kindly note down. I think all were there only now. Actually,
Yes, ma'am.
yeah. So people, just to go through the question paper. Already we have seen this question paper. It is not new to you, but even I'm just discussing. Okay. So party, I think I have discussed on that time. You have seen You always have to see 5, 6, 7, 8 from part A. Okay. 5, 6 from third unit, 7, 8 from fourth unit. You all know na third and fourth unit. You know the timing 2:30. So kindly log in by 2:20. Actually, we will be login. So 2:20. Be ready with the A4 sheet paper. In the A4 sheet paper, top of the A4 sheet paper, write your subject name. SEC 1317. Principles of embedded system, your name, your register number, date. Okay, everything you will write. And then once I will upload the question paper in LMS, kindly download it and then start writing. Okay, so 2:30 to 3:30 for writing. After 3:30, stop writing and try to upload your answers in LMS. Okay, so be with all these things, and be Monday onwards you have a regular exam. We are not postponing any exams for you, even though you have some what is that placements and all there. The assessment will be continued. Are you clear or not, ma? Okay, I think we will skip the party. What is this risk? You all know what is the use of memory organization. Data memory and program memory is separated. You have to explain about the Harvard architecture. Okay, what is internet enabled system? That you have to write it in general only. You all know all about internet enabled only. The distributed embedded system can able to work. We can do see centralized, decentralized, and all you have to explain. Then four types of data transfer in USB. That is high speed, full speed, and all you have to explain. Okay. Now you just see today they asked about priority inheritance. What is priority inheritance? Jay Prakash, you have to explain in a single word. Priority inheritance, na low priority get involved and high priority get blocked. Something will happen up and downs in my love our life now. The same thing
Yes,
is
ma'am.
priority inversion. Okay.
Okay.
Okay. Okay, now I will move on to part B, ma. You just note down the question. I'm not very specific. Tell that I just note down the question. Jayshri, Jayshri.
Ma'am.
Yeah, you note down the question, ma. While I'm ask you to read out the question, you have to tell me. I will show
Ma'am.
the in the PPT what you have to write. Are you clear? Okay. First one is about third unit, architecture of pick. First question. Then the second question is assembly language instruction. Are you clear? Third unit, you have only probability is having three questions in pick. Okay. One is architecture, another one is instruction, and another one is addressing modes. Okay. Only three probable question, but we will see what we one by one. Architecture of pick and assembly language instruction. Remember, here they didn't mention pick, but we all know third unit we studied about two processor. What are they? What are the two processor we studied, ma, in third unit? What are the two processor we studied? I have to cry for you people, ma.
Pick
What?
on the arm
Ah,
7.
very good, very good. Pick and ARM7. So you have to say that ARM7 we didn't studied any assembly language instruction. So this is about pick only. Are you clear? Okay. The next question you see, discuss about the different types of network used in distributed embedded system. With neat sketch, explain the architecture of CAN. Actually, fourth unit you have a lot of questions will be there. They can ask any serial protocol, or RS-232, RS-485, one protocol. The another protocol is CAN is one protocol, and the next one is I2C, that is another protocol. SPI, that is another protocol. USB, that is another protocol. Ethernet, another protocol. So six protocols we have. Are you clear, ma? We have a six protocols. So people try to understand that any protocol they can ask. The another thing is they can ask about the distributed embedded system. Are you clear? 15, 16, 17, 18. Just look out that four questions in your part B. Jayshri, have you noted, Jayshri?
Yes, ma'am. Written, ma'am.
Yeah, okay. Thank you, ma. So the next one, we will see the next question paper. You see, just see risk and risk they are asking frequently. Okay, when you see that what is meant by pick, I think this is your assignment question. Okay, and explain the different types of addressing. You all understand that PIC microcontroller only we are studying the architecture, addressing modes, assembly language instruction. In ARM 7, while we are discussing, we are just learning about the architecture and the registers alone. Okay, so if they ask about addressing now, that denotes PIC only. So PIC, what are the two addressing modes? Direct addressing mode and indirect addressing mode. Very simple. Don't forget that. Okay. Then compare CISC and RISC, that we all know well, very well. Okay. Then give the application of embedded. Hey, what you have done such a thing. So you can write any one of your application. It's a 2 mark. No need of block diagram and all. Just you explain, or else you put the simple block diagram. Are you clear? Okay. Then next one is uh, you just see addressing modes of PIC microcontroller. I told you now, pick only 3 probable questions. PIC microcontroller, architecture, addressing modes, and another one is instruction set. Okay. Then write in detail about pipeline architecture. You all know pipeline architecture. Na, we were expecting ARM 7 has to explain. Okay. We all know ARM 7 having how many pipeline architecture? ARM 7 la எத்தனை இருக்கு? Yeah,
Three,
it's all.
ma'am.
Yeah, very good. What are they?
Fetch, decode, execute.
Yeah, very good, very good. So, and ARM 9, you have a, I think I have put the PPT for that, that you write the pipeline architecture. Okay, you have to try to increase and write. See, again, they ask about CAN, controller area network. Then see the same question. Last year question also repeated here. Briefly explain distributed embedded system with neat diagram. Are you clear? Jayashri, have you completed, ma? Have you
Yes, ma'am.
written
Yes, ma'am.
50? Okay, okay, okay. So 15, 16, 17, 18 over. Okay. 15, 16 na third unit, Jayashri. 17, 18 na fourth unit. Okay.
Okay, ma'am.
Now you see again same question. You need how to repeat pipeline architecture. In third unit they asked pipeline and then addressing modes. Previous year question paper alone. And fourth unit they ask about which interface ma RS-232. So don't see this question. It is out of syllabus. It's not our code ma. Don't get confused. SECX 1066. So it's not. But moreover, some 80 to 90% of the syllabus is matched, and I got that question paper. So leave the 18th question ma. 15th, 16th, and 17th. So now they asked. So far, 2 question paper we have seen can, and now they're given RS-232. Are you clear? Okay. Have you written, Jayashri?
Yes, ma'am. Written,
Yeah,
ma'am.
yeah. Thank you, Jayashri. So the next one, okay, 2 mark. You just see. This is your assignment question: minimum and maximum bus arbitration. That is priority. Is which bus has to be not arbitration is not a priority. Judgment. Okay. So what is the need for bus judgment? Why it is needed, and all will be decided by the bus arbitration. In can we use the bus arbitration technique? Which bus has to be done, whether we have to take which message, and that and all bus or that has to decide. Can area having the bus arbitration logic. So many protocol is having bus arbitration is judgment, why it is need of. Okay, then what do you mean by network based design? That is, you have to explain about embedded network. Then differentiate between, so sorry, this is the next question. Then draw the status register format of. So fifth and sixth is your assignment question. Okay, 7 and 8 is that is from fourth unit. Okay, you leave these questions. Now you come to the next question, ma. You just see it is somewhat uh, I think they asked all the thing. Memory organization of PIC microcontroller. Don't get panic. It's a part of architecture only. So the part of architecture only we will explain what is EEPROM, what is program memory, and what is data memory, and all we will explain. That is PIC microcontroller. And draw and explain the architecture. See, architecture they are repeatedly asking. Then instruction set of PIC microcontroller. So PIC microcontroller probability, I told you 3 questions, but the fourth question is what? Memory organization. Okay, then you see RS-232 bus and pin configuration. Actually, we have studied the 9 pin RTS, CTS, carrier detector, and all. Okay, then next they ask about I square C bus also. Okay, then you see write short notes on. So you have to write 8 marks for USB bus and can also for. So you always study for 16 mark. Then try to compress and write for 8 marks. Okay, don't study for 8 mark and don't write for 16 mark. Okay, study for 16, and if they ask in 8 mark, compress and write. Or Jayashree, have you taken?
Ma'am, 1 minute, ma'am.
Hmm. After completing, you tell me. First year CSE, sir. Even section.
Written, ma'am.
Okay ma. சார் லாஸ்ட் அவர் தானா? தீபான்னு ஒரு மேம், அவங்க அங்கதான் எடுத்துட்டு இருக்காங்க. நான் சைன் போடுறவா? ஈஸி ஈஸி இதுல 9:30 வரைக்கும் அங்க எடுப்பாங்க. அப்புறம் அவங்க அங்கதான் எடுக்காங்க போனாங்களே. சரி நான் போட்டுறேன். சிஎஸ்சின்னு எழுதிடுறேன் சார். ஓகேவா? நான் சைன் போட்டேன். ஓகே. Yeah. So I will move on to the next question, ma. Okay. So you just see RS232 9-pin serial connector. You have to draw USB protocols, memory organizations, and define embedded system. The same thing only they have given. I think if you studied your part B, part A will be automatically get covered. I think you see, kindly see the instruction set. Okay, and compare CISC and RISC. Both they have asked in same question. Pin diagram of PIC, I told you on that time. Pin diagram, it's very difficult for you to remember, but you can put it in group and write. Are you clear on that? Okay. And see, I square C bus they have asked. Don't write the 18th question, ma. It is out of syllabus. Okay. Jayashree, have you written 15, 16, 17?
Ma'am, no, ma'am. Wait, ma'am.
Okay. And actually 15th is repeating and 16th is your pin diagram. Okay. But I think 17th is only the I square C. I think inter-task communication I will teach after your assessment. Okay. So, and one more thing I have to announce for you, ma. I think Monday to Thursday only you have a class for you. So Friday you don't have any class. So Friday I will prepare gate questions in embedded. Are you clear? So Kagoth will be conducted on Friday. So after completing the inter-task, half an hour for Kagoth. Okay.
Ma'am, written, ma'am.
Yeah. Thank you. Thank you, ma. I think that's it. Okay. Now what I will do, first I will share the third unit PPT. Students, can you able to see this PPT, ma'am? Okay. So this is uploaded in LMS. Okay. So please kindly listen to me. Don't get your, I think 80% while I'm free speak very frankly, you are seeing the PPT and writing. So don't do that. You try to read it once again and you see what is in the PPT at the time of examination opening, and you people are writing something. Okay. CISC and RISC, they asked in 2 marks now. Only 4 points are enough. Or normally I'm saying, not only for my exam, normally 4 points are much enough. Even it is asked in 6 marks, you have to write all the points. So the first PPT itself, I put CISC and RISC comparison. Very explained well. I need not to going to teach you. Remember. Okay. Then this is about what is CISC, RISC and all. Okay. Leave it and all. So you just see students pipelining. They have asked so many times. I think by pick instruction also you can explain about this pipeline. Okay. Now you leave it. These are the applications. 2 mark. Okay, typical applications of embedded system. It's a 2 mark. Okay. Okay. Now I have told you pin diagram of peak. That is the answer for this question. So pin diagram na don't remember this points and all. You all know here 5 ports are there. So near if you see to that how many pins na that will be allocated, then the supply pin and all. So you see to that and you write it that, don't try to remember all the points. It's very difficult for you. Okay. Okay, this is about all the pin explanation. So if they ask about pin diagram, this slide and this slide, that is enough. Okay. Now, peak microcontroller architecture. Second question. Jayashri, if I missed any question in peak microcontroller, you tell me. Okay. So I have told you,
Okay, ma'am.
I have told you pin diagram, that is over. After pin diagram, I am now telling about architecture. You start from here. Okay, architecture, you have tried the features and I have put it as a point. Okay, first CPU, second memory organization. Okay, and you have to compress and write. Third serial communication, fourth interrupt, fifth, sixth, seventh. Actually, you remember all point you have to write correctly, but only one thing is memory organization alone you have to compress and write while you're writing architecture, because memory organization how many slide ma, 1 2 3 4 5 6 and all, 7 is there. So 7 and 8. So here you have to write one, only one thing. I think you have to explain this alone for your architecture. So you have to explain CPU, second memory organization. Okay, then leave all this slide. Third serial communication, fourth interrupt, fifth timer. Okay, sixth CCP, seventh IO ports. Okay, eighth, ninth, then the finally you have to draw this diagram. Okay, why I put this and all now, this is the core features that is not needed for you. Okay, you just explain that 9 points along with this architecture diagram. Okay, if they ask memory organization alone, are you clear? If they ask memory organization alone, you are supposed to explain this diagram. This diagram, it's very important diagram. You should not skip this diagram. This diagram, and then this, and this you need not to put. This is to understanding purpose only. You can't remember. Are you clear? Till that you have to explain. So I have told you what you have tried for architecture. This is for to understanding purpose only. Okay, this is the difference. Leave it. Then status register 2 mark they were asking. Okay, leave it. Then now addressing modes, you see, from here addressing mode started. Direct addressing mode, indirect addressing mode, over. Okay, so then the next one is instruction set. So instruction set, you have to write all the instructions. I think this one table is enough to write all the instruction set. But the one thing you can't able to remember correctly now, here we have grouped according to the instruction. Addition, and then we have bit operation, then program flow instructions and all. Data transfer we have splitted, but here it will be according to byte, bit and literal. You can explain that or you can explain this single. Okay, don't write this cycles, 14-bit code, status affected nodes and all. Mnemonics description is enough. Okay, and then this is not necessary for your theory. So pick microcontroller, I told you what are the questions. Pin diagram can be asked. Architecture, then the third one is addressing modes, then memory organization. Only 4 questions. Are you clear? Kindly note down. Jayashri, if I skipped any question in pick microcontroller ma?
Ma'am, no,
Instruction
ma'am.
set, ma'am.
Huh?
Instruction
Instruction.
architecture, addressing
Ah,
mode,
then pin diagram. Only 4 questions in
memory
pick.
organization motivation கேட்டிருக்காங்க மேம்.
Memory
memory
organization.
organization ஒரு 16 mark.
அதான் memory organization இங்க போட்டிருக்கோம்ல. This is you have to explain. Memory
Yes,
organization.
ma'am.
Okay, 3 memories are there: program memory, data EEPROM memory. When you write for your architecture, this slide is enough. But they asked memory organization alone in 12 mark na, you are supposed to explain all these things. Are you clear? Okay, now ARM processor, they don't think they will ask anything, but that syllabus doesn't contain ARM processor. But you have to know these are all application. Leave it. Okay, ARM processor, we have only, so you just see pipeline organization diagram and all I have explained. Okay, ARM processor, first registers of ARM processor I have written. ARM registers, what are the registers? It's all about registers of ARM processor. Okay, till that ARM processor registers will come. Okay, so here I think still that ARM processor registers, then ARM processor architecture, this diagram only. Are you clear? So ARM processor, you have only two questions. One is ARM architecture and another one is what? ARM registers. So kindly include that question, even though it is not in the question paper, because the particular syllabus doesn't contain ARM processor. Okay, that's why the ARM question is not there. But in our syllabus, we have ARM7 processor. So you have only two questions in ARM7 processor. One is registers and another one is architecture. Registers now where you have to start? You have to start from there. Registers, and what are the registers are there? This diagram, CPR, current program status register, then save program status registers, and what are the different types of processor modes. Okay, and this is the organic. Okay, ARM7 register na you have to write till the status register. Okay, second question is ARM7 ARM processor modes. Modes na you have to start it from here and you have to write till this. Okay, that is ARM processor modes. Then the third question is ARM architecture. Three questions can be asked. ARM7 registers, ARM7 processor modes, and then ARM7 architecture. Three questions are there. So you would kindly note it in your notebook. Are you clear or not? Yes, three questions are there. ARM7 processors alone. Okay. Today what I will do, I will upload one crisp PPT for you. Okay. I will try to upload it by today or tomorrow. Okay. I think you people will download on Sunday morning, Sunday night, or Monday evening. I don't know when you will download. I will once again upload it. Wherever not needed, I will remove it and I will upload it once again. Okay. Then ARM7 architecture, you have to explain all the component. Then you have to explain with this diagram. That's it. Okay. So you leave it. So third unit is get over. Okay. Next, I will move on to fourth unit. No. It's not my fourth unit. Once again, I'm not getting my fourth unit. Yeah. Students, kindly listen. This is one important one. Okay. You always understand 7 question probable question. In third unit, what are the probable question now? Pin diagram, PIC microcontroller architecture, PIC microcontroller addressing modes, PIC microcontroller instruction set, and PIC microcontroller memory organization. Okay, the remaining questions are ARM7 processor architecture, ARM7 registers, ARM7 modes. Okay, so these are the questions in uh, third unit. Fourth unit, 6 protocols plus distributed embedded system. 7 questions are there. So we will see one by one. So first we will see distributed embedded. I think where you have to now, you have to start it from here. What is distributed embedded system? Okay, what is advantages? How we will share it? What are the types? All these things you have to explain for distributed embedded. Are you clear? Till that you have to explain. You have to compress and explain all the distributed embedded system. Then the second question is about RS-232. You all know na, this question they were asking repeatedly. That is your RS-232 pin detail and all. Have you seen all the 9 pins? What are the pins and all? They have asked. So this diagram is very, very important. They may ask in 2 marks or they may ask you to write about RS-232 in 12 mark. Okay. So I think we will directly enter. You start from here, ma. That is about to that only I have explained. I will upload whatever necessary for you to study. The remaining slides I will remove and upload for you. Okay. So those who want to in detail, you kindly download it today itself. Tomorrow I will upload the whichever Nakure. Tomorrow morning I will upload it. So whoever want to delete all the thing, you delete and upload it. You have download it. I will delete whichever is necessary for your exam. That alone. Okay. So RS-230 now start from here. You have to explain RS-232 specification, pin diagram, this RS, this is DB data bus, 25 pins are there. This and RS-232 speed I have to, and what are the type RS-485, what is RS-485, and what are the types are there on comparison between both. So you have till RS-232 and RS-485. Okay, and next to CAN. Is a very important question. They have explained about CAN. CAN, what is CAN? This is to understand CAN, and this is after CAN you draw. Don't draw before CAN. Okay, this is our diagram which is necessary, and then you have to. This is not needed. CAN applications and CAN advantages and future scope of CAN. You have to start from here. CAN. Okay, we have three types of CAN controller: standalone, integrated, and single chip. Only single diagram. Standalone, na, these three are separated. Okay, integrated, na, they will fuse these two in a single IC. Then single chip, now all this will be fused in a single chip. Okay, then this is not CAN controller architecture, same thing only. Now you have to explain, this is the next message frame. Okay, what are the basic CAN, full CAN, how they have differentiated, and what is CAN frame. This you, for all protocol, the frame is very important. They will ask, so this diagram is very important. Okay, and data format, we have two things: basic and extended CAN. And then you have to explain what are all the field contains. And typical CAN mode, we have a four kind of frames: data frame, remote frame, error frame, and overload frame. Okay, and this about the detail, this diagram and all not necessary, leave it. So arbitration, I told you two more method to use to arbitrate and determine the priority of the buses. To avoid the collision only, we always go for the arbitration logic. Okay, so here node C will wins the arbitration, so it will transmit. The next node B will arbitration a judgment or priority, where which node has to transmit the message. Okay, so CAN is over. The next one is I square C. What is I square C? I square C configuration, futures, and these are some example diagrams. Okay, and this is the message frame of I square C. Okay, that you have seen. And the next we have all about I square C only. Okay, then SPI, next protocol SPI we have explained. I think this diagram will explain the entire operation for you. And what are the advantage and disadvantage. I compare three buses: I square C, SPI, and URT. Can be asked in 2 mark, na? This can be explained. Okay. Most of the time they ask you to compare I square C and SPI. It's one of the important 2 mark, I square C and SPI comparison. Okay, then USB, it will be all in detail. What are the USB and what are the types and all. You try to, you can't able to draw the diagram. At least this diagram and this diagram you can able to draw. So, what are the message frame of USB, and what is wireless USB? Actually, wireless USB is not in your syllabus. To understanding purpose only, I have taught wireless USB and all. Okay, that is the another advancement in USB. Okay, then Ethernet. Okay, so Ethernet, what is Ethernet, how it is working. So this is the message frame of Ethernet. Okay, so I will try to reduce the number of slides, and I will try to upload it. Okay,
Ma'am,
Jayashree, yeah,
ma'am,
என்ன question விட்டுருக்கமா?
explain the necessary sketches to enable intra communication among peripherals using I square C bus, ma'am.
I square
Diagram கேட்டிருக்காங்க ma'am.
I square C. I will remove whichever necessary. I will put that and I will upload it once again. I think you need not to download it. I will upload one more PPT. Okay, as a study material. Okay, I square C I left somewhere. Okay, what is the thing they have given, ma? Jayashree?
Ma'am, intra communication among peripherals using I square C bus, ma'am. All the
Same
necessary sketches, diagram கேட்டிருக்காங்க ma'am.
diagram. Okay, diagram na. This is one of the diagram. I square C. Have you seen this diagram? I think you can't able to see. Oh, they came into internet. Wait. See, I square C intra communication. You all understand I square C and SPI. We have a master slave, but I square C only half duplex. SPI will do full duplex communication. So while they ask about specifically the diagram, na, this is the diagram. Okay, your microcontroller, along with how your peripheral devices get connected. This is one way. And the another diagram you see here, one temperature sensor, one timer, and one LCD display. But my master microcontroller is this. But you see, this is my message frame. Message frame will be communicated only. I'm having two line. One is my clock line and another one is my data line. Yellow color denotes the clock line and green color denotes the data line. So how my data is transmitted? Okay, so this is my message frame. Are you clear? So my start condition should be there and stop condition. We have a two way of communicating the I2C. What is one way now? One, we will send the address, then we will send the data, multiple data. Sometime we will send the multiple address and we will send the single data. So single address, multiple data can be sent. And another one is single address, single data, single address, single data will be sent. So whatever may be the particular slave address, we will send the data. Okay, so you have to explain this about the message frame. You have to start from here. This is the I2C communication bus. So first you have to draw this two diagram. Is clear, ma? This diagram and this diagram. After that, you have to tell that my message frame contains this much of information. So that information you have to explain it separately. Yes, Jayashree? Any more
Okay
question?
ma'am. No
Okay.
ma'am.
Okay, I will try to upload the question. Okay, Jayashree. Now will you take whether you are having PPT, ma?
Yes ma'am.
Yeah, you kindly share it. I have gave the share access. Okay. So students, one more thing. All the best for your exam. Do well, ma. Okay. Try to
Thank you
good
ma'am.
score good marks. Okay. Thank you, ma.
Ma'am start பண்றேன் ma'am.
Start பண்ணு. 35 பேர் sir. Yeah, you start, ma.
Okay ma'am. Now I'm going to take the application of microcontroller which is based on tachometer. Already we have seen tachometer in our machines lab to measure the speed. The tachometer is electronic digital transducer. It is used for measuring the speed of a rotating. The number of revolutions per minute is a valuable information for understanding any rotational system. In the tachometer, the components used are this at 89C2051 microcontroller. This is
Yeah.
the circuit diagram and the
Yeah.
working
Mm.
working of a microcontroller is when the light sensitive probe in tachometer there is a light sensitive probe is there. When we shows that light shot towards the spinning dial, the will read in speed and on. The only requirement is first we should place any contrasting color. Strip of the white tape is ideal on the spinning object. When each time the tape spins, the probe momentary increase light is detected by the phototransistor. The microcontroller will adjust the rotation and when the value is shown in this 7 segment display, 4 digit 7 segment display. Ma'am, that's it, ma'am.
Yeah, actually, she had put a elaborated diagram for you. Most of them put it as a block diagram. Very good, Jayashree. And she have explained how our digital tachometer is working. Olden days, analog tachometer, and now we have a digital tachometer. And she have explained well how it will measure the rotation and all. Yeah, good, Jayashree.
Thank you, ma'am.
Yeah. While taking attendance, all will enter. Anyone have prepared, ma'am?
Ma'am, I will take, ma'am.
Yeah, you also share,
Register
ma'am.
number 88, ma'am. Neetu
Name
Priya
is.
will share.
Okay. Or else I am also having. Shall I share?
Okay, ma'am.
Okay. Yesterday you have sent me in my WhatsApp, I think so.
Yes, ma'am. Deepa sent it.
GSM based
Advanced
security.
security system. Yes, ma'am.
Yeah.
Yes, ma'am. Good morning, guys. Today I'll take about GSM based advanced security system by using PIC microcontroller. Next slide, ma'am. Ma'am.
Yeah, I am here only. Let's
Yes,
move
ma'am.
in. Okay. Yeah.
Yes, here the PIC microcontroller is interfaced with PIR sensor, keypad with LCD display, GSM module, and RFID reader. The right side is the complete embedded system of this topic. Next one, ma'am.
Mm.
As the top right is the PIR sensor.
This
It
is
is the
PIR sensor.
yes, ma'am, top right. It is the electronic sensor that measures infrared light radiation. Here it's based on motion the
Swati,
first level of
your
security
voice is interrupting,
system
Swati.
is the PIR sensor. It
Swati, your
detects
Swati, your voice is interrupting.
human body. If PIR sensor, if your
Actually,
hello.
yeah, your voice is not. We are not continuously getting your voice. There is interruption. I think where you are getting the signal well, stand there and talk. Okay. Now you talk the same slide. Will you can able to talk? You are started PAR, na?
Yes, ma'am.
Okay.
Yes, ma'am.
Yeah.
Yes, PIR sensor is the first level of detection. Here it's used to detect human at border. If PIR sensor is not detected means system will not go for further security system. The second level of security system is RFID module. It's bottom right corner, ma'am.
Okay.
Yes, here it's a wireless, it's used to electromagnetic field to transfer data. An RFID reader is used to detect RFID code of human at border. If RFID reader detects the RFID code, then further security steps will occur. If it's not detected means RF if it's not detect RFID code means the system will not go for further security steps, which is the GSM module. And the informations will, if it not detected, the informations will reach to headquarters using GSM module. And GSM module is left side top one, and it looks like a mobile phone which is helpful to send information of unknown person to a headquarters. And the LCD display is used to display the data on the screen. With the now here keypad is the third level of security system. Once the RFID code is detected, then the keypad is used to enter security code. And if the secret code, if the secret code is not valid, the information is going to send to headquarters using GSM module by call or SMS. Next slide, ma'am. And this is the complete setup of this project. Once the once if we give 5 volt supply, the board is on, it will wait for human detected by PIR sensor. Once the human detected by PIR sensor, LCD will display swipe RFID card. RFID reader will read RFID card data, and if it's not matches with the pre-entered data, then GSM module will be activated and SMS will send to headquarters. Once if RFID card data is matches with the pre-entered data, then LCD will display as enter secret code. Once the secret code is correct, the gate will be open. If it's not correct, the GSM module will be activated and the call or SMS will go to headquarters. That's all, ma'am.
Yeah, very good. Actually, she get
Thank
explained one innovated one. I think day-to-day life in all software industries and in most of the places they were using this. So I hope everyone have understand. So I think one more thing I will do, ma. Um,